Hi, my name is Hashwindiran. My matrix number is 241 362 and 986. In this lab test, I will demonstrate the generation of a carrier signal, a modulating signal, and an amplitude modulated AM signal using MATLAB. So the given parameters are carrier frequency, which I use as a FC here, 5 kilohertz, carrier amplitude, which I put as a EC 9, and modulated frequency FM, which is 500 hertz, and modulating amplitude EM 4.5. So for question A, I generated the carrier signal. First, I defined the carrier frequency as a 5 kilohertz and then the carrier amplitude as a 9. Next, I created a time vector from 0 to 10 millisecond. The carrier signal was generated using the equation of VC. VC equals to EC times sine times 2 times pi times FC times time. So this produces a sinusoidal waveform with a frequency of 5 kilohertz and an amplitude of 9. So here is the graph. So as you see, the graph shows a high frequency sine wave because the carrier frequency is 5 kilohertz. Many cycles are observed within the 10 millisecond interval. So we go to the next question. So for question B, I generated the modulating signal. The modulating frequency is set to 500 hertz and then the amplitude is 4.5. And here also the same sinusoidal equation is used and the timestamp is from 0 to 10
Raila.
but with the modulating frequency. This signal contains the information that will later be transmitted through the carrier. So I will run this program. After we run this program, we get a sine wave. So the graph shows a lower frequency sine wave compared to the carrier signal. Since the frequency is only 500 hertz, the waveform changes much more slowly. So from here we can learn that if the frequency is higher, our sine wave will be we got a lot of sine wave. But if the frequency is low, we can see our sine waves is beautifully designed here. Go to question C. Okay. For question C, I generated an amplitude modulated signal with a modulation index less than 1. So the modulation index is calculated using the equation of m equals em divided by ec. Substitute the given values, which is
Aku
m
tengah
equals to
buat-buat.
4.5 divided by 9, which give a 0.5. Since the modulation index is less than 1, the AM signal properly modulated. So the AM equation combines both of these carrier signal and modulating signal. So let's see our graph. So the graph show the carrier's wave from amplitude varies according to the modulating signal. The envelope accurately follows the shape of the modulating signal. There is no distortion, therefore the original message can be recovered successfully at the receiver. So next we go to the question D. So for question D, I investigate the effect of the over modulation. Instead using of the calculated modulation index, I manually set the modulation index to the 1.5. Since the modulation index is greater than 1, over modulation is occur. The same AM equation is used to generate the waveform. So we go see our waveform. The graph show distortion in the envelope. The envelope no longer follow the original modulating signal correctly. This phenomena is known as over-modulation. As a result, the receiver will have difficulty recovering the original information signal accurately. So, when in conclusion, MATLAB was successfully used to generate carrier modulating AM signal. These results show that the modulation index plays an important role in AM transmission. Uh, Modulation index less than 1 produces a clean waveform, while a modulation index greater than 1 cause overmodulation and signal distortion. Thank you.